Hey everyone, welcome back. In this video, we're just going to introduce the concept of two-sample hypothesis tests for population proportions. So we kind of introduced this in one of the previous videos. But the idea here, again, is we're trying to compare two different populations to one another, right? So is the proportion of population 1, is it the same as the proportion from population 2? Or is it different? So when we have a null hypothesis, we can write it either way, whichever way makes more sense to you. We can say the population proportion 1 minus population proportion 2 is equal to 0. We kind of did this in the last video, right? If you do some algebra and you add P2 to both sides, then it's the same as saying, the P1 is equal to P2, right? So we assume that they are the same. We assume that there is no difference. And then our alternate hypothesis, we test to see if the difference is not equal to 0, right? Which is equivalent to saying that P1 is not equal to P2. In our confidence interval formula, right, we saw that the standard error of the difference between our sample proportions was equal to this. However, the above formula is a logical dilemma, right? If we're assuming that they are equal to 0, then we're assuming there is no difference, right? So if the populations are the same, then in theory our samples should be the same, right, or very similar. So basically the standard error would just always be 0, right? If the difference inside is 0, the standard error of 0 is 0. So instead of using this formula for the standard error in our hypothesis tests, we need to use a technique called pooling. So basically, pooling is just combining your two samples together and creating one new pooled proportion, right? This p hat pooled. So you calculate it by adding up the successes from the first sample size, from the first sample, adding it to your successes from the second sample, right? So this is the number of people or things in your sample that had that desired trait you were looking for, right, from sample 1 and sample 2. And then you add up the two sample sizes together, right? So we're basically just combining our individual sample proportions together into one new sample proportion. And so once you have p hat pooled, to calculate the standard error of p hat pooled, right? Or the pooled standard error of p hat 1 minus p hat 2, we use this formula here, p hat pooled times q hat pooled, right? Which q hat is just 1 minus p hat pooled, right? And so we divide that by the first sample size 1. Then we add the same thing, the pooled times 1 minus pooled, over our sample size 2. And then we take the square root. So our z test statistic is going to look like this. It can kind of be simplified. If you don't want to have to calculate the p hat pooled times q hat pooled, you can just calculate it once, multiply it by 1 over n1 plus 1 over n2, but whichever way makes more sense to you. So that's pretty much it. In the next video, we will revisit this same example, right, that we last calculated a confidence interval for, but this time we will perform a hypothesis test. Okay.